Hey guys, after a long hiatus, yes, I'm finally back at the GE800. So when I last left off, pretty much finished recapping underneath, and I was puzzling how would I get at the stuff underneath the CRT, which I've left on while working on this. Left it on for a few reasons. One, it's quite well secured and it's very easy to rest to this chassis on its sides. CRT is fully supported and work underneath. I don't want to take it off because once you do, you're going to have to put it back in and readjust to some of this stuff, particularly the ion trap magnet and exactly where this is positioned in relation to this stuff, which is the electromagnet focus coil and the deflection yoke. But I got to admit, I have to. I'm never going to be able to get at. There's some caps down in here and electrolytic here and a few parts on this little sub-assembly here. I just can't. Even if I take the tubes out with these coils and such, it's just too hard to get in there. So out it's going to come. So how do we get it out? Well, there's a little bit different than other sets I've worked on. So I guess I'm just going to have to pop off the ion trap, loosen up this band, which honestly is pretty crude. I don't even know if there's any type of padding between this metal. No, it doesn't appear to be any padding between the steel band and the CRT. I'll put something down under there, at least some electrical tape or something to provide a little bit of relief between the two. High voltage connects down below, kind of dead middle. So that gives me some idea when I put this back in that the anode lead or button should be basically pointing directly down. If I'm lucky, none of this stuff sticks. Sometimes these yokes shrink over time and gain grip on the glass neck pretty darn tight. In the past, I've had to use heat gun to heat this up and expand it a little bit. I've heard back in the day they would actually hook up a power supply to the yoke and allow it to heat itself up by running some current through the wires. But I don't want to do that. Honestly, this is kind of a crude assembly. The electromagnet's just around the glass neck, and there's not a whole lot of clearance between that, so I could definitely see this getting banged around and smashing into that glass. You can adjust it here by manipulating these thumb screws. So you loosen up this one to move it back and forth, and you can loosen up this one and rotate it around a little bit this way to find a sweet spot to get the best focus. I think there's actually a fine focus control. We'll look into that a little bit more. That's been modified a little bit down behind, but this focus control here is actually a rotary switch. I think it has 3 positions on it. Anyway, let me get the CRT out and put it away for safekeeping, and then dig into this stuff some more. Okay, as I feared, it's not so easy. Why? Because the metal chassis comes up over the bottom of the CRT. You can't slide it out this way. You need to lift it up a little bit. Can't do that because of this stuff. It'll put pressure on the neck and snap it. So I'm going to have to loosen up all this stuff and move it around, which is exactly what I wanted to avoid doing, but I just can't. So I'm going to have to get some pliers on that guy. That's for the yoke. This one I can loosen up a bit. So, well, I mean, I've got this video and I've taken reference photos, so that will certainly help. Looks like there's a screw. No, it's just for a wiring harness. Yeah, I think that's all there is just this thumb screw for the yoke. I got it out, and I got to admit that was a little nerve-wracking. These glass necks, that is the weak point. Glass here much thinner than, say, the glass on the front. So I don't think it's, I don't know. I don't know if it's a rebuild. There's a weld way down here, particularly when they would rebuild it. The cut would be more like back here, so it might just be from when they manufactured it. Well, there's nothing else. I can clean it up before I put it back in. So here's what we got. So let's just kind of hang it loose now. And I think somehow I can take this whole thing off. It's got to be, probably from inside the high voltage box, there's got to be something attaching to this, and then this whole thing I can take off and put on the side and then get down there. Man, I don't know how they serviced these things back in the day. So there's 2 paper caps down there, a few resistors, and then a couple more, or maybe 3 paper caps up here and some power resistors. That little bit of metal is pretty important. That makes contact with this outer conductive coating to ground it, which provides a forms a capacitor to filter the high voltage. I could also get down in here and clean. I put this cardboard up front so the speaker wouldn't get damaged. There's the output transformer to the speaker. Some little rubber pads here that originally were pliable and cushioned the CRT. Now they are utterly rock hard. I'll pop those off. I do have some rubber sheeting I think I bought from Granger ages ago. I'll replace these as well. All that old rubber has turned to rock. Alright, I am finally done with the recap and hopefully the bulk of the work. I checked a lot of the resistors, not all of them. Found a few out of spec and replaced them. I did not test all of the mica caps. There are a number of these old style domino mica caps, which in the past you could pretty much assume that they were good, not so much anymore. But we'll power up the set first before we dive into those. I just wanted to quickly recap a little bit on what I did, because there are a number of odd things about this, to put it mildly. One, there's a lot of caps. There's a lot of electrolytic caps in this thing. A few less now because some of them were doubled up in parallel and I replaced them with one cap. But let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, at least 11 electrolytics that I can see right in front of me. I think there might be a couple more hiding. That's a lot for a set from this era. And part of it is because they have a voltage doubler, transformerless design, which requires a little bit more filtering and a couple caps for the voltage doubler action. And also, well, in some regards, I suppose it's a bit over-engineered. Like, for example, I'm not sure why they put a 50 microfarad cap on the focus coil. I would think the DC would be pretty well filtered at this point. Or with this goofy 2 different B- rails that have a 150 microfarad cap between those two. So it's a little odd. But back to this. So I did end up adding a few terminal strips. I don't normally like to do that, but I didn't really see much choice. Some of you, I'm sure, have been thinking, why don't I just restuff the caps and reuse existing wiring and leave all that alone? They're really hard to get at. Even after I took the picture tube out and all that, there's still a couple of them that are, especially one, over right in the middle of the chassis. That's really hard to get at. To disconnect all the wires, to extract it, to remount it, I thought that would be more invasive than what I did. To recap, there were a number of caps running along the side here. There were 4 of them. Some of them were in parallel, like these two, and these two in particular. Those were the 4 underneath the chassis. Those each got converted into a single cap. So these 4 caps became 2 caps. Selenium rectifiers used to be up here. They have been replaced with these 2 1N5408 3-amp 1000-volt diodes. Overkill, but certainly very robust. There was a surge-limiting 5-ohm resistor. I replaced that with one a bit larger for a number of reasons. One, these are more efficient than seleniums, so they drop less voltage. Also, line voltage is higher today. I also want to provide, just as they did back then, some surge limiting to help protect the diodes from the inrush of current when you turn the set on. So once we get this all powered up, once it's working, I'll run it some like 123 volts or so and see where B plus is at, and if I need to, I can adjust this resistor value. It's not that critical. People talk about it all the time. What resistor did you use when you replace the selenium? Sometimes I don't use any. These sets can run off like plus minus 10% easily on the line voltage B plus. So if it's a little bit high, a little bit low, I don't care, as long as it's in the ballpark. Some other oddities. So I had to put a terminal strip down in here. One, because they had used the rectifiers that were here as tie points, and two, there is a resistor down here that goes over to this field coil. So if we look at this power supply, there's a bunch of different voltages off of here: 275, 265, 145. The 275 is the highest potential, right before the filter choke, and that goes over and around and around and over to the primary on the audio output transformer. I guess they really thought those 10 extra volts were going to make a difference. I don't know. Or they wanted to isolate it from the rest of the set before that filter choked, so in case maybe some sound could feed back into B+. I don't know. But regardless, there's a 220 ohm resistor and a 10 microfarad cap. That output transformer is mounted to the speaker over here. So that 220 ohm resistor's on this terminal strip. And the 10 microfarad cap is over here, pretty close to where the original was. So that's what that's all about. I'm very glad I put this cardboard shield on the front, because I came close. I'm sure I would have put a hole in the speaker cone without it, because I have bumped into this a number of times. Okay, so enough talking. Before I power this up, I want to quickly review everything, make sure everything's hooked up, and then I actually want to disconnect the B plus temporarily, which I can do with just this one wire down here, go into the power resistor, surge limiting resistor, and I want to turn on and make sure all the tubes light up. Totally independent circuits. So off the AC line, we got part of it that goes up to the power supply, the other part goes down to all the tube filaments. I took some of them out while I was working on this, so I got to put those tubes back in, and I want to make sure we got continuity to everything. Then we'll try it with the B plus, see what happens. Alright, let's give this a go. Got all the tubes reinstalled. I'm using a 5AXP4 test CRT. It's going to be an issue because this is self-focusing. It does not need an electromagnetic focus coil. In fact, this will bend the electron beam so much we probably won't even see a glow on here. But let's get this powered up first and make sure everything else is okay. Got it plugged into my PR57. Set off. This is off. PR57 on. Remember, B plus disconnected. Just want to get the tubes to glow. And dial this in to about 117. I'm going to flip it over to current monitoring mode. Should draw, I think, 600 milliamps or so with just the tube filaments. So let's see what happens. Well, that's awesome. Kind of made a weird crunchy sound when I turned it on, but we're settling right down to a little over half an amp. The output voltage tends to droop when current's being drawn, so this is down to about 115. I'll bump it up a little bit. Now remember, I replaced the filament dropper resistors with diodes and a current surge limiter thermistor, so these 75s are gone. And if you recall my earlier design work, at 117 it's going to be limiting it to a bit less than 600 milliamps. But it should still be fine to get this out working. And if the output voltage is more like today's that we commonly see in the US, it's going to be a bit over 120. So if I put this up to like 123 or so, that's still about half an amp, but also this thing isn't super accurate. I'm not that concerned about that right now, but very good. So it turns on. Everything's lit up. So, without further ado, let's hook up the B+, and worst case scenario, you get a puff of smoke. What I'm hoping, though, is that we hear a crackle, maybe a little hiss out of the speaker, and maybe some indication we have some high voltage, like a little bit of crackling or static. I really don't think we're going to see any glow on the CRT, but we shall see. Now I've got the chassis on its side, so I can measure voltages underneath. It's pretty stable if you put the high voltage box side down. I've got my voltmeter attached to the main B+, which should be about 275, and remember, you can't use the chassis for your ground reference. You have to figure out a good point for the B- connection. I have the set turned on, the PR57 is turned off. If you hear a loud hum, it's more likely the PR57 than the TV because it tends to hum a bit. I expect this is going to draw in excess of 1 amp when I turn it on. Well, it should surge up as the power supply does its thing, and then drop down, waiting for the tubes to warm up, and as they warm up, it should draw somewhere 1 1/4 amps, maybe a little more, if everything's working right. So, here we go. Okay, it shot up to about 1 amp, and I dropped down to about 0.6. We got 276. How about that? 275, 274, tubes warming up, current draw is increasing. 0.7 amps. 0.75 amps. B+ has dropped quite a bit now. What the Variax putting out? Oh, it's only down to 102. Let's bump that up to 117-ish. So that dropping resistor I have in there, assuming everything else is correct, is too big. Current draw, only 0.8 amps. That seems a bit low. Let's try turning the volume up. Alright. We got cracklage and humming. That's excellent. Do we have high voltage? That's a little hard to say. I'll get a high voltage probe out in a moment, but before that, let's see if we can detect anything. Let's see, brightness, contrast, are these guys? Yes, there is a raster. How about that? Of sorts. It's just kind of at the bottom, brighter than the rest of it. Again, that focus coil is going to kind of be screwy. To really use one of these test CRTs properly, you need to either physically remove this from the neck or electrically disconnect it. And so that's kind of part of the power supply. I'm not going to electrically disconnect it. The wire's got a bit of length. Usually if you take off like this wing nut, slide it off the neck, and you just have to keep it supported somewhere so it doesn't bump into anything, but leave it in circuit. Alright, that's cool. Well, I don't know exactly what the current draw is, but I thought it would be a bit higher than that. And probably would be if this wasn't so low. That resistor's getting pretty darn toasty too. I got a 40 ohm resistor in there, and the original was a 5. So maybe I should go with something more like 10 ohms, or even just all the way down to 5. I think that's far too big. But hey, how about that? Well, let's go for broke and clip in an antenna. Well, or just an alligator clip with a long wire, and see if I can tune in channel 6. Or at least hear if there's any actions that change channels. I'll pick up the knobs for this set. I know I put them aside for safekeeping. I don't know if I can turn this without it. What's tuning? Well, it's definitely not the original knob, but it'll do. It'll do. I don't think I've tested any of the tubes. I kind of like to not do that, so it just adds more fun to the troubleshooting. It's doing a little something when I change channels. No hint of reception. The tuner in this is a wafer style tuner, which is a little primitive. It's just a big rotary switch, and it's not shielded or anything. It's just this. So it could have dirty contacts. Oscillator mixer tube could be bad, or the RF. Well, there's 3 tubes in there. We've got our RF amp. Actually, it's got two RF amps, and the 12AT7 is both the local oscillator. Oops, sorry guys. It's got 2 RF amps, local oscillator, and mixer. I think it uses 1 RF amp for the low channels and 1 for the high channels. Or no. So it's got a balanced input. It kind of looks like they're amplifying each section independently, like these are kind of like mirror images of each other as it goes down through. That's, well, GE kind of did their own thing, it would seem. It's very remotely possible with the lower B plus that it's not enough to get the local oscillator running, but it's not all that far, so that seems unlikely. Well, let's at least check some of the other voltages. So we should have a 145 rail. That's pretty critical there, so let's figure that out. That's in between these 2 caps over here. And that is sitting at 129, so okay. Seems like the power supply is more or less working right. Screen's doing something to change channels too. Alright, I am gonna put a smaller resistor down here and then flip this thing back down, and we can start poking around more with the controls and check out some of these tubes. I switched to a strong signal source and discovered a few things. One, I'm losing my raster because of that focus coil, and the only way I can get it back is to physically move this test CRT off to the side. So I definitely want to get that focus magnet off of there. So now we can see we are actually getting some reception, bit of sound. But I cannot get a lock. The hold controls are doing something, and it's getting close. So it might be a matter of a component value may have drifted off, or the sync separator circuit might be a little flaky. But that's a really good sign. We're definitely getting reception. But I think the gain's a little weak. I got the contrast maxed out right now. If I back off a little bit in the contrast, it's just gone. I think the thing that makes the most sense to do right now is to test all the tubes. All these issues, bad sync, bad gain, could definitely be because of weak tubes. So let's take care of that and eliminate that as a possibility, or maybe it'll fix all the issues. I swapped out most of the tubes with good ones, or swapped them into different positions, and things seem a little bit better, but I still can't get the horizontal to lock. So I think what I need to do is adjust the horizontal coil on the back of the set. This guy, it's sort of like a coarse frequency adjustment. The shaft sticks out the back of the chassis. Use an alignment tool on it, and let's see. I haven't dealt with the focus coil yet, so I'm going to hold the picture tube. Huh, well, that's all the way at one extreme. It seemed like it was getting close, but no cigar. Try going the other way, but I think that's making it go to a higher and higher frequency. So, what does that tell me? So, since I swapped out this horizontal oscillator tube, I think it's either a resistor that's way out of spec or a cap. Oh boy, that's close. Gain seems to be a little bit better now too with all the fresh tubes. But wait, whoa, whoa, whoa. Hey. Well, it's weird because I've got that to lock by adjusting the contrast control, which sort of affects the gain. Well, I mean, it does affect the gain. Vertical lock is really hard to get to, so that tells me the problem probably lies in the sync separator circuit because that's common to both. Really hard to get a vertical lock. If I increase the contrast, the horizontal lock goes out. Interesting. But hey, very encouraging. Well, I chucked tubes, I swapped tubes, got some slight improvement, adjusted various controls. They all seem to be doing what they should, like in terms of the vertical hold and horizontal hold, except that I can't get it to lock reliably in either horizontal or vertical. Horizontal, yeah, is stable right now, but if I move the control just a little bit to either side, I lose horizontal as well. Which tell me the sync circuit isn't working. I went over that. I checked the resistor values. They're all within spec. So that leaves me to the mica caps I'd mentioned earlier, which, well, there's a bunch in there. There's one there. So this is the sync amp and clipper, or separator and clipper right here. And this feeds both the horizontal circuit and the vertical. So I'm going to go into the vertical integrator, up here, and there's a horizontal down here. So since the vertical is especially bad, I don't think it would be either of these two caps because they feed into the horizontal, but that is definitely a big potential problem. Now I could fire up my scope for sure. I do have this nice chart here. And they show that sync clipper pin 3, we should have a nice strong pulse there. And on the input to the grid, we should have this. So, it's probably the quickest thing to do. So I will try to hook up my scope. I'll have to put the set on its side, I guess. I do have some socket extenders, like I have on the CRT here with test points you can get at, but that tube is way back there, and I think even with the extender, actually if I use the extender, it's going to bump into those control shafts above it, so that's not going to work. I have to run this set on its side. Got the scope on pin 1 of the sync clipper, and we should have 40 volts peak to peak. It's more like 4 volts peak to peak, maybe 6 volts. Those are the horizontal pulses. It's having a hard time syncing on. If I decrease the frequency, we should be able to see the vertical pulse. There's the signal on pin 1 of the sync clipper, which should be 40 volts peak to peak. Instead, we've got around 4. So there's definitely a problem. They don't show anything prior to that, unfortunately, on the sync amp input stage. But for sure, see, 314 seems like a very likely place to check. I will also check the plate voltage on pin 5 and see if it's 45 volts. And likewise the cathode on pin 3 and see if it's 145. Before I just start checking everything, let's think about this a little bit logically. Check out the schematic. So, not only do we have lack of sync, but I have to have the contrast up pretty high to get an image, and the sound is not very loud at all. Which says to me we've got a weak signal going through the whole set. And if we check out where the sound comes from, it is picked off after the video detector. Some of these early sets had a separate IF for sound and video. So if for example, you've got strong sound but weak video, you could just check out the video stage. But this has weak sound and video, and they have a common IF. And contrast basically controls gain up at the front end. So I think we've got a weak signal coming through somewhere in here, or there's some component failure in this area. So let's check this stuff. Now I've already swapped out all these 6AU6s, 6A05, 12AU7, and a 12AT7, made minor differences. I also noticed that these IF tuning slugs are still locked in their factory positions. They put like a little bit of glue basically on the adjustable shafts. Also, this is a little bit different. They do not have IF transformers per se. They're kind of like more like RC coupled. So these 100 picofarad caps here between the plate and the grid. It's a little bit different. And these maybe are like peaking coils. So I don't want to mess with that. So instead, well, let's check some basic stuff. So the main B plus voltage is 265, 145. Those are pretty much accurate. So let's check some other things. I also checked peaking coils, at least a couple of them, and they seem to be okay. So initially I was thinking, well, the problem's just on the sync circuit, like there's one cap down here, but no. I mean, yeah, that could still be bad, but I got other issues going on too, so let's check things a little bit more comprehensively. So in addition to the schematic, we've also got this block diagram with key signals here and there. So here's the IF, and they have key points here, and voltage readings like 15 volts, 140. I already checked these, and these are pretty close. That was my first thought. There's a problem in the IF chain. Now, one of these 100 picofarad caps could be bad, for sure. Could be a problem with the tuner. I hope not. Difficult to get in there. So we've got 1, 2, 3, 4 decks. There's a big old rotary switch. And the components for the oscillator, mixer, RF amp are down underneath. Really quite inaccessible. So I hope we don't have a problem down there. I checked these two resistors already. There's some that are pretty awkward to get at. However, if there is a resistance chart in here, I don't think there is. I think it's kind of a Sam's thing. But if there was, I could check that. There is a scanned copy of the Sam's photo effect for this online, but the quality is pretty crummy. So I'm not sure if I can read the values off of it. I can put some socket extenders in some of these tubes to read some voltages, but they don't give too many. Like, I don't see any voltages on these tuner tubes. Yeah, they don't. Like, there are no voltage readings for the oscillator or this RF amp. All I see is, well, 15 volts here and 180 up there. And they do give 125 on the converter tube. So at least I could check those. The IF, so here's the tuner, and there's 3 tubes on top of that. The IF, it's that tube, that, and that. Those are the 3 stages. These, I'm guessing, are those 100 picofarad coupling caps. Yes, they are mica. Could be leaky. I believe that is the 6AL5 detector tube. And then buried under that nest of wires is a 12AU7 two-stage video amp. And there's DC restoration. That's the other half of the 6AL5 detector tube. One half there, the other half over there. So, I think the problem lies between there and, well, here. So, it's a bit to check, but I think this stuff is actually working pretty well. So, let's get to it. I'm just about done testing tubes. All the tubes I've tested so far are up here, and just about every tube in this set was good. Except one 6AU6 has a little bit of a plate shortage indication, as does the 6AL5. Actually, this one is testing quite bad. Not only is the short light lit up, but the needle's way over. So, this guy could definitely be causing a problem. The only issue is I've got three 6AL5s, because before I even tested the tubes, I was swapping some around. I think that's one of the tubes that came with the set. Now, there's two 6AL5s. One is used for sound and one is used for video. I think I swapped out the one for video and left the one for sound in place. Either way, that's really bad. 6AL5s are pretty reliable. It's just two diodes, essentially. And they generally, they might get weak, but I don't think I've ever seen one shorted before, so that was a little surprising. And let's see, this one tests really good. So, let's put all these good tested tubes back in and see what difference it makes. So what I had initially done is I pulled out all the tubes that came with it, pretty much, and put in known good tubes, because basically because I was impatient and didn't want to test them. But now that I've tested them all, they all test quite good, which makes me think that whoever did work on this set, like replacing the line cord and putting the fuse holder in, checked the tubes and replaced any that were bad. Because it's pretty unusual on a set this old to not see at least some weak tubes, and none of these tubes are weak. Well, I put all the original tubes back in to test it good, replaced the 6AL5 and 6AU6 that had shorts, and the set is working better. Horizontal sync is pretty reliable. Vertical, we still have rolling, but it does occasionally lock, especially if I tweak. I think it's a linearity control on the back of the set. There we go. I still think the gain is a bit weak, so the volume is up 100% right now. And you think it'd be deafening at this point, and it's just kind of at normal listening levels. And the contrast, if I back it off to anything below about 3/4, it just blanks out. So right now it's about 75–80%, and that's 100%. Back off a little. These two vertical bright lines you see here are probably could be eliminated with adjusting the horizontal drive, or I haven't tested the tubes inside here. The horizontal output tube or damper tube could have issues, so I'm not too concerned about that right now. So I've pretty much eliminated the tubes. I've checked a number of the resistors in the IF chain and checked some voltages, and everything seemed to be okay. And the alignment, I don't think it's ever been tweaked. They put a little bit of glue on all of these adjustments, and none of them have been turned. There's a pretty simple IF too. So oscillator mixer tube, 2 RF amps, and then 1, 2, 3 stages of IF. Just right in there. Then the video detector, video amp, picture tube. Really straightforward. And as far as aligning it, this doesn't use transformers. It uses coils. I think they're set up like peaking coils. And it's actually capacitively coupled between the stages. 100 picofarad, 100 picofarad, 100 picofarad. First, second, third stage. Detector, 2-stage amp. So I've pretty much eliminated these resistors. I mean, checked them, they're all good. Possibly one of these 100 picofarad caps, which are the old mica domino style, could be leaky, which may be impacting the gain a little bit. It's hard to say. This is a tough time with restoring a TV or a radio when it works fairly well, but not perfectly. It's easy to find, like, when there's something that's open or burned out or dead, but when it's kind of working, then you got to get a little more thorough and exhaustive with checking everything. I've done a few other checks too, like I checked the antenna input, that this twin lead is good, that the coils in here and down here have continuity. Yes, there are also mica caps here. Generally though, the RF antenna coupling isn't an issue. Generally it's not the tuner. The components underneath this tuner are pretty hard to get at, so I hope it's not that. The alignment doesn't appear to have been messed with, so I don't think it's that. So I'm a little bit scratching my head if it is an issue with the gain. But what else is to check, except for those mica caps? So that's the obvious thing. A little bit tricky to test them because, well, it's a little. You have to disconnect one end of them, and they use pretty heavy gauge wire on these leads, and you can potentially damage the cap just by unsoldering one end to test it. Because of one of the failure points with these caps are made from like 2 halves of Bakelite kind of glued together. And when you twist those leads, you can actually damage the body of the cap, or if you apply pressure to it. So I'm not crazy about testing them, but I think I may have to. Not the end of the world. 100 picofarad mica caps are pretty readily available, so I could just shotgun those as well. A little bit expensive, but, you know, do what you gotta do. But, yeah. So the main notice, the focus a little bit blurry. That's, again, the nature of using this test CRT. I found a way I could adjust this focus coil. If I cock it just the right angle, it doesn't mess it up too much, but if I tilt this a little bit, blanks out the picture completely, so I have to have it at just the right angle to get an image, and I think that's affecting the focus, so I'm not concerned about that. I can't even get it back. You got to get it just right, because what's happening is this electromagnet is actually partially, this is a fixed magnet too. I was surprised to discover that. Usually it's just an electromagnet or a fixed magnet, but not both. Unless over the years this electromagnet magnetized the steel, I guess that's a possibility. Well, I'll have to fiddle around with this and find that sweet spot again, because now Anyway, so I think my next course of action is to check the vertical integrator. I believe those are all plastic film caps that I replaced. I checked those resistors, they're all within spec, but there's 150 picofarad and there's 1000 picofarad. So I think it's time to get out the capacitance bridge and test a whole bunch of mica caps. Should mention there is another cheap and dirty and quick way to check these, is to just cut the lead. So you're not stressing the body or the solder joint or any of that, and you can very quickly snip, test it, and then if it's good, you can kind of butt the ends up together and solder them back together. I've seen sets where actually I could tell that somebody had cut a lead and then resoldered it back together when they determined that that component was good, but it does somewhat weaken the joint, so it's not my preference to do that, but in this case I might, just because there's so many of them and they're a little hard to get at.